Hello, good morning, and welcome to Magic Academy. We'll be looking at isomerism. This isomerism, I always like students to take note of some terms that are related. Something like isotopy, something like polymerization, and all the rest of them. But isomerism, as used in organic chemistry, is defined as the existence of two or more compounds having the same molecular formula but different structural formula. You see a compound that share the same molecular formula but their molecular structures are different. That is what we call isomerism. I have written this one. Let me now explain it. Isotopy, on the other way around, is the existence of two or more atoms having the same atomic number but different mass number, and so on and so forth. I don't want us to go into that. Let us just face isomerism. So we have types of isomerism. We have the common one is structural isomerism. Structural, we have geometric, and we have optical isomerism. So we'll take them one by one. Even though this optical, I have a separate video for it, but I'll just give you an insight so that you get yourself prepared for the full video. Structural isomerism is just like we have butane. Butane, everyone here knows that butane is C4H10. That is the molecular formula. So butane has two isomers. That is normal butane, one, two, three, four. This is a normal butane. The current is here is C4H10, it's normal butane. And we have an isomer of this. Remember, both of them will share the same molecular formula, but their structural formula will not be different. Look at an isomer of butane. Thank God we've learned these ones before now. So if you watch, the structure of this one is not the same thing with this one. So the name of this one is simply 2-methyl propane. If you can remember, 2-methyl propane. You can start numbering from any side. 1, 2, 3. So carbon number 2 has a methyl group. CH3 is a methyl group, which is attached to carbon number 2. And 1, 2, 3. Three carbon atoms, the root of the carbon that has three carbon atoms is simply what? Group. That is 3 2-methyl propane. So if you watch it carefully, you will see that if you count this one, two, three, four carbon atoms. Let's count the hydrogen, even though I don't like counting it. All I know is it must be complete. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the hydrogen is what? Complete. They have the same molecular formula, but their structure is what? Different. That is what we call structural isomerism. Remember, as the number of carbon atom in a compound increases, its isomer also increases. Like I've told you, butane has two isomers. Pentane, which has 5 carbon atom long, will have 3 isomers. Hexane, having 6 carbon atom, will have more isomers than all these ones. So as the number of carbon atom in a compound increases, the isomer will always increase. Don't forget, pentane has 3 isomers. Hexane, 4, and all the rest of them. That is what we call isomerism. The same molecular formula, but different structural formula. Let's check that of pentane. Pentane is a C5H12. Normal pentane is a 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So fill others with hydrogen. This is a normal pentane. It's a normal pentane. Now, an isomer of pentane will be 1, 2, 3, 4. Fill others with hydrogen. And you see another one. 1, 2, 3. And this one enter this one. Fill them with hydrogen. So if you watch, these are three, just fill all these ones with hydrogen. Let's not, okay, let me do it. Fill others with hydrogen. So if you watch this very carefully now, watch it very carefully now. This one, so that this one will have its own space. This is normal pentane, C5H12, normal pentane. Now see one of the isomers of pentane, 1, 2, 3, 4, 5. If you count the hydrogen, it will still be complete. This is simply 2-methyl, 2-methyl, 1, 2, 3, 4, butane. And this one is simply 2, sorry, 2,2-dimethyl propane. The important thing to note there is that they have the same molecular formula of C5H10. If you count the C and the count hydrogen, it will be the same. 1, 2, 3, 4, 5 for this one. 1, 2, 3, 4, 5 for this one. 1, 2, 3, 4, 5. These are the three isomers of pentane. Remember, as the number of carbon atom increases, the number of isomers also increases. Let's take geometric isomerism.